Now let's see a small numerical based on the degree of reaction. So here you can see that what is given, an outward flow reaction turbine has internal and external diameter of runner 0.6 meter and 1.2 meter respectively. Here first thing, it is an outward flow reaction turbine. That means let's draw the system first. So if we take this as runner, as it is an outward flow, this will be your inlet velocity triangle. As this is an outward flow reaction turbine, here this is the D1 and this is for D2. That means here you can see that D2 is more than D1, as it is given that diameters are 0.6 meter and 1.2 meter. So the bigger one, that is 1.2 meter, is D2. So D1 is 0.6 meter and D2 is 1.2 meter. The guide blade angle is 15 degree. Guide blade angle means this alpha. Here is the guide blade angle which guides the velocity V1 towards this runner. So alpha is given as 15 degree. Velocity of flow through the runner is constant. That means Vf1 is equal to Vf2 and its value is given as 4 meter per second. If speed of turbine is 200 rpm, also head on the turbine is given as 10 meter and discharge at the outlet is radial. That's why I have drawn it like this. So beta is 90 degree. That means Vw2 is equal to 0. And what we are supposed to find is runner vane angles at inlet and outlet. That means theta and phi. Also work done by the water on runner per unit weight of the water striking per second. That means we are supposed to find work done per unit weight of water. Next thing we are supposed to find is the hydraulic efficiency and the degree of reaction. So let's solve this. Now to find theta, we need 3 parameters from the inlet velocity triangle. Here we know only alpha. Other than this, we don't know anything. So let's find U1. So U1 is equal to pi D1 n upon 60. Pi into 0.6 into 200 divided by 60, and we will get the value as 6.283 meter per second. Similarly, we can find U2 also. So U2 is equal to pi D2 n upon 60, which will be needed in further calculation. So pi into 1.2 into 200 divided by 60, and the value will be equal to 12.566 meter per second. Now we have got one more parameter. Let's see for the third parameter how we can find that. Here we can see it is given that Vf1 is equal to Vf2. So from Vf1 and alpha we can find Vw1. So we can write here as Vw1 is equal to Vf1 upon tan of alpha. So 4 divided by tan of 15 degree, and its value will be equal to 14.928 meter per second. Now let's move for the theta angle. For theta we have now Vf1 as well as we have u1 and Vw1. That means we can take this distance. So for tan of theta we can write Vf1 upon Vw1 minus u1. As we know, Vf1 is 4, Vw1 we have found as 14.928 minus u1 we have found as 6.283. So from here we will get theta is equal to 24.83 degree. Now let's move for the another angle, that is phi. So here u2 is known to us, Vf2 is also known to us. So simply by using a tan phi we can find phi angle. So let's write down tan phi is equal to Vf2 divided by u2. So 4 divided by 12.566, and its value is equal to 17.65 degree. Now we have got two values. Let's move for the work done per unit weight of water. Now work done, this is equal to 1 by g. Here as we see here that beta is 90 degree, that means Vw2 is 0. So the value of the work done per unit of Newton of water or per weight of the water will be equal to 1 by g Vw1 u1. Now we have all the values of this, so let's put, that is, so multiply by 14.928 and u1 is 6.283. We will get value of the work done per unit weight of water is equal to 9.561 Newton meter per Newton. So alpha is 15 degree and theta is 24.83 degree. Now as it is a reaction turbine and we have considered that beta is equal to 90 degree, that means Vw2 is equal to 0, then the degree of reaction we can find from the equation 1 minus cot of alpha divided by 12 of cot alpha minus cot theta. So equation will be equal to 1 minus cot of 15 degree divided by twice of cot of 15 degree minus cot of 24.83 degree. If we solve this, we will get the value equal to 0.1877. So here you can see that this value is between 0 and 1. For all degree of for Francis turbine, the degree of reaction always varies between 0 and 1.